Hey everyone, I hope you're doing well. So, in the previous videos, I showed you how I built a programming language called ELO and wrote a self-hosted compiler for it. And the language is stack-oriented, meaning that you have a stack on which you push and pull values to and from. For example, 2 pushes 2 onto the stack, 3 pushes 3 onto the stack, and plus pops the top 2 values, adds them, and pushes the result onto the stack. So after this, 5 is on the stack. So we can turn this into a program. For example, if we make a function called foo with variables x and y, and it returns an integer. So this would be a valid function, but we need a main function which returns an int, which is the exit code. Let's make this x and y, of course, and then call the function add. So this should call the function add. It should take the arguments, add them, return it. So 5 should be returned by this program. Let's build the compiler. So it's in a couple of stages. Now we have a compiler which takes this program and turns it into assembly. So if we write this to a file like this and then compile it. So we've got test.o, turn it into test. Okay, and we check the exit code of test, which is 5. So that's a short recap of how the language kind of works. And our goal was to write a self-hosted compiler for it, which is a ELO compiler written in ELO itself. In the last video, I showed you that we reached that goal and that the compiler could compile itself. However, there was one problem, and it was really slow. It took minutes to compile the compiler, while the Bootstrap compiler, which was written in Python, only took a couple of seconds to compile the compiler. I needed a way to measure which functions took the most time, so we know where we could optimize the code. And the program that measures this is called a profiler. A profiler checks, well, it takes samples of the function call stack, in our case every millisecond, and I've added this profiler to the standard library. It uses 3 syscalls, Linux syscalls. As you can see here, setTimer uses the setItimer syscall. So let's look at that one. setItimer, it sets up a timer which triggers a sig alarm signal, in this case, every millisecond. So then we use RT_sig action to tell Linux which action we want to take on a certain signal. So we tell, in this case, we say every sig alarm signal, we want to handle it with this function, this handler. And then we use RT_sig return to clean up the stack. So these syscalls are used in the profiler. We have a function to initialize the profiler. So it sets up the timer, it sets up the signal handler, and it sets up the profiler, which is a list of samples and a lock to make sure we don't sample when we're still sampling. Then we have the handler. So what this does, this is triggered every millisecond by the sig alarm signal. And then it just simply adds the name of the function from which the current function was called and appends it to a list. And then at the end of the program, we use profiler dump to output all these samples. So for example, if we compile the compiler like this, so normally it just outputs assembly code. So the compiler has a couple of options. One is a profiler. So profiler. Now it outputs all these functions. So we know which functions actually take up the most time. So what we then do, we use sort and unique, and then we sort the list, and we get a list. And we see that malloc takes up the most time. So 153 samples, so 153 milliseconds of the time we were in malloc. So this way I was able to see which functions really needed to be optimized. And if we look at the git log, we look at starts with. So this is the first function I optimized. What we saw is on my other computer, it improved from 276 seconds to 180 seconds, which is a lot better. Then we continued. We continued with optimizing isWord. And this went from 3 minutes to only 9 seconds. So that was way better. So it was clear to me then that the Lexer was the main issue. And then we optimized list append from 9 seconds to 2 seconds, so much better. And then we optimized concat, which concatenates strings. And this was a great milestone because our Python implementation, the Bootstrap compiler, was actually slower than our own self-hosted compiler. That meant that we could get rid of the Bootstrap compiler, because normally I would keep it because it was faster, and now it's not faster, so there was no use for it anymore. So yeah, we're fully self-hosted now. We don't have a Python dependency anymore. So as you can see, the profiler proved to be extremely helpful. So we might even use it for future programs. So let us check the improvement. So this was the last time before optimizing. So let's see, the functional tests took 9 minutes. So we went from 9 minutes to, let's see, to 17 seconds. I mean, that's so much better. 9 minutes to 17 seconds. That's amazing. Yeah. All right. So what's next? So now that we have our programming language, let's build an actual program with it. And I'm thinking about creating a game engine, which uses the SDL library. We'll use this library to create a game engine. I think it will be really cool to eventually create a small weird game for a game jam, for example, in a toy language like ELO. But that might be cool for the next video. For now, thanks for watching. And if you have any questions, please let me know in the comments. And I hope to see you in the next video. Yeah. Bye bye.